Yes, Winky.
Yeah. Okay, just give me a minute. Let me open my PPT. Just give me a minute. Are you able to see my screen? Okay, okay, fine. So let's okay, just yeah. Okay, so let's start our today's session, guys, on BigQuery. In our previous session, we have just seen what are data warehousing concepts, why we need data warehouse, what are fact tables, what are dimension tables. All these things we have seen in our previous session, and also we have seen a quick introduction related to BigQuery, correct? So let us understand, let us refresh about BigQuery, what we have discussed, right? So what is BigQuery? BigQuery is a scalable serverless cloud data warehouse solution by Google, right? So it's a scalable serverless cloud data warehouse solution by Google. And advantages or features of BigQuery, it has very strong streaming ingest support, and then very strong batch data ingest or bulk loading support, and it supports AI ML. BigQuery has internal functionality on ML models, and fully managed serverless. We have discussed in detail about what is serverless, right? How it works and all, right? And automated data transfer service. So that has inbuilt data transfer service, but majority of the times we don't use it, but it has inbuilt data transfer service. Uh, Highly scalable. The architecture of BigQuery is highly scalable and which is horizontally scalable, and access control features. It always utilizes Google internal IAM, identity access managers management security, and federated queries and the API integration. It supports all the API related integrations. It supports Python API. It supports Java. It supports all the different Go. It has command line utility called BigQuery, BQ command line utility. We'll call it as it supports SQL, right? So the major thing is it is SQL compliant, so you can write all your SQL queries in BigQuery. So that is one of the biggest advantage that we have, right? So we can connect to BigQuery with Python. We can connect with BigQuery with C++. So you can connect with BigQuery with BigQuery command line utility, right? So these are all some APIs that we can integrate with BigQuery. And federated queries, as I've already discussed, you don't need to transfer a data to BigQuery if it is in GCP database systems. So you can write and run queries from the BigQuery itself without transferring the data, right? So these are all the quick introductions that we have seen with respect to BigQuery. So any questions still now, guys, in terms of data warehousing concepts or in terms of BigQuery? Any queries or confusions? If you need clarifications, we can discuss. Any questions before going further? Any questions?
No.
Okay, fine. So if that is the case, then we will try to go ahead with the next concepts in our session. So if you see, if you divide our services into different segregations, right? So one is the ingest, another one is the store, process and analyze, right? Process and analyze, and then explore and visualize, right? Explore and visualize. So if you see all these service segregations, you can actually use a BigQuery data transfer service in the ingest section, and then BigQuery in the storage section. And you can also use BigQuery for processing, right? I mean, you can write your data queries. You can write your SQL queries to process your big data, and you also can write your stored procedures and call those stored procedures from different APIs, right? So that is also possible in BigQuery, and that's why we can place BigQuery in the processing and analyzation part as well, right? So similarly, there is a BigQuery BI Looker engine which will be supported for reporting and visualization. So that is also will be considered as a reporting purpose. So if you see the services that we are going to discuss in our sessions, right? So in the ingest section, so we can actually go with cloud functions and PubSub. I'll show you how to work with cloud functions, and I'll show you how to work with PubSub. Okay, and we have already seen third party ingest processes like Python based data ingestion to GCS, and then NiFi based data ingestion to GCS, right? So along with them, we will see how to ingest data from a cloud function, or we'll just see the cloud functions, how actually we will utilize them, and then we will see the PubSub, right? So similarly, we have seen cloud storage, GCS, right? And then we are going to see BigQuery, right? And we have RDBMS systems, which are OLTP systems, right? So which is Cloud Spanner, right? Cloud Spanner and Cloud SQL. So these are database systems inside the Google Cloud Platform. Okay, and then BigQuery is a cloud data warehouse, and Bigtable is a no SQL database, or a key value data store or database in Google Cloud Platform. So if anybody have understanding on HBase, in Hadoop we have a NoSQL database system called a HBase. So Bigtable is the exact representation of that HBase. Okay, so we have a NoSQL database service, and we have a cloud data warehouse service, and we have RDBMS based services, right? And then we have a file system, right? Object storage file system called cloud storage service. And then in the processing and analyze part, you will see a lot many things, wherein you have Google's proprietary data flow. uh, Data flow is one of the processing service that has been provided by the Google, and data proc is the service that has been provided to support the open source technologies. And then the budget friendly data processing service. Data flow is very costly. The reason being, it's a Google's proprietary service, and it is auto scalable by itself, and it is serverless, all these things, right? So BigQuery reads are very costly, writes are pretty cheap. When you're loading data to BigQuery, it won't cost you much, but when you're querying BigQuery, it will cost you a lot. Okay, so but data proc is actually where you have a little bit control in on your usage, right? So these two things are serverless. BigQuery and Dataflow are serverless. They can scale automatically in the background, and they will cost a lot to your project, right? That is why actually we will always limit using BigQuery in terms of processing. We will always process the data using data proc, because if we want to process big data, so we can use data proc Spark service, and then we will load the data to BigQuery, so that the reporting or API or visualization dashboard will be connected to BigQuery on a scheduled fashion. The reports will be refreshed, or the machine learning will be triggered on a periodical fashion. Okay. So, and we will apply the quick retention policies on BigQuery, because BigQuery storage is also cost, the coalesces, right? So, and then AI platform, these are all AI and ML related services. So we don't need to discuss about them. And this is a separate wing called reporting and visualization. So which is data lab, data studio, and looker. So these are all will be utilized once the data engineer has loaded the data to cloud data warehouse or NoSQL database. By using Looker or Data Lab or Data Studio, some other reporting team will be presenting these results to the end users. So this is how actually a quick segregation on GCP services. Okay. Uh, after that, let's proceed further with the BigQuery architecture. BigQuery is a Google's cloud data warehouse system, right? So Google's cloud data warehousing system. So here, if you see in BigQuery, or for that matter, in any of the data warehouse system or database, right? We need to have two things. We need to have three things. Sorry. So one thing is the storage, right? Data storage. And the second thing is the compute power, right? Cores and RAM, cores and RAM, CPU and RAM. We need these CPU and RAM, right? And the third thing is the execution framework or engine, which will actually execute your queries on by using the compute on the storage, right? So the execution engine and the compute and then the storage, and there should be something which will be connected, which can be connected with the storage and compute, right? So that is what network will call it as. So network protocol, right? So there will be a storage. You name any database, guys. You name any database, even if you take Oracle or Teradata. So there will be a data storage where actually the data will be stored, whatever the tables that you are creating, whatever the data that you are loading to the tables. So there will be a storage space that is needed for the database or a data warehouse. And the second thing is cores or CPU and memory, RAM, right? So when you install this data warehouse or database in any of the server, right? So that server will be having some capacity of RAM and some capacity of cores, right? So when you have this storage and compute, there should be one execution engine, right? There should be one execution framework or a technology or a software which will be utilizing this compute and executing the client request on the storage, right? So this is the sequence if you take any of the database, right? So here in BigQuery will support the streaming ingest, and it supports very huge bulk loading as well, right? Bi- as like other data warehousing systems, BigQuery also have a distributed storage. So distributed meaning the data will be stored in multiple different nodes, right? Multiple different nodes. So for the storage, it has a different technology. It is not your GCS. Be very very clear. Your BigQuery and your Bigtable will be having a different kind of a storage system. We'll come to that in later point, but we need to understand decoupled storage and compute first. Okay, we need to understand decoupled storage and compute first. Okay, so what do I mean by that? So let us understand that part quickly. Okay, so in cloud systems or in cloud data warehousing systems, you take Snowflake, you take data bricks, you take BigQuery, you take AWS Redshift, whatever it is. Okay. So the major concept in cloud is your storage and your compute both are decoupled. Okay. But if you take your traditional data warehouse systems or database systems, the storage and compute are coupled, meaning your tables data and your compute, the queries that you are running, both will be coupled in a same server, right? So in your traditional data warehousing systems, what will happen? The on-prem data warehousing systems that I'm talking about, right? So what we will be having, we will be having a single server. Okay, this server will be having some 128 GB RAM and 64 core processor. Okay, so this is the server configuration. Now in this server, what will happen? In this server, what will happen? So we will install Oracle, Teradata, or SAP HANA, for that matter. You take any traditional data warehouse, right? Oracle, SQL Server. In SQL Server, what we have done, guys, we have taken our laptop as a server or a machine, and we installed that SQL Server database or data warehouse in our laptops, right? So from where the storage and compute coming to SQL Server, so it is coming from our laptops. Guys, are we clear? Are you able to understand what we are discussing?
Yes.
Right? So, in production systems or in production data warehouse systems, what they will do is they will take a very big server, very bulk server, and they will admin teams will install and configure your database systems in that servers. Okay. Now, what will happen? Oracle and SQL Server will take the resources, meaning they need storage and compute, right? So, and also these servers will be having SSDs or hard disks, right? So I have one. Okay. Now, when you install this Oracle and SQL Server, the scope of this Oracle and SQL Server are limited to this server only. Your data storage and then your compute will be limited or will be under this server scope. Okay. So all the client requests, all the queries that we are submitting will be coming to this server, right? Queries. And these queries, what we will do, we will try to send to this database, and then we will execute, right? That's what we do, correct? And when they are executing, the queries will take these resources only. Okay, so that's why I said in our traditional data warehousing systems, in on-prem data warehousing systems, the storage and the compute are coupled in a single server, coupled in a single server. That means the compute and storage will be in a single place or a same place. Okay, but in cloud, what will happen? So the cloud, the storage and compute will be decoupled. Be very, very clear. The storage and compute will be decoupled. Okay. So storage will be someplace, and then compute will be coming from some other nodes. Okay, storage will be in some nodes, compute will be in some other nodes. Okay, this is what cloud will follow. You take any cloud data warehouse, you take Snowflake, right? So in Snowflake, what we do, we will store the data in S3 buckets, and then Snowflake will utilize that data store. Okay, and that's the reason in Snowflake we have a t-shirt sized warehouse systems, right? So for the compute, you have to select the warehouse. For data storage, you don't need to have any warehouse as such. You need only user access. That's it. Okay, but when you want to run queries, you need to select the warehouse in Snowflake.
So similarly in Databricks also, you need to select the cluster, right? Your data will be stored in any of the cloud. It may be in Azure or it may be in AWS S3, right? For that matter, Databricks, we need to select the cluster for compute. So storage will be at some place and compute is different, right? So with this, what we are doing, we are separating tasks into multiple parallel things, right? So which will increase the performance of your queries, right? So it has its own problem, meaning the data is not in the same place. So it has its own problem, but the problem is the advantage that we'll get is the performance of you, the performance increase in your query, right? The query resources are not limited now, so the query resources can scale to the maximum extent, right? If you are coupling your storage and compute, your resources are limited. Be very very clear. Your compute resources or your storage resources are limited. But when you decouple, they are unlimited by themselves, right? So storage, you can increase your servers horizontally. You can scale as and when the storage is coming to the threshold. You can increase your server capacity or nodes capacity horizontally. You can attach, and then when it comes to compute, automatically when you are submitting big queries, they can scale automatically in the background. So that is the reason of decoupling storage and compute, right? So BigQuery also follows the similar decoupled storage and compute methodology, right? So BigQuery has its own storage, okay, and then it has its own compute, okay. For the compute, it has its own infrastructure. For the storage, it has its own infrastructure, okay. So the thing that is going to connect these two compute and storage, right? So compute and storage is a network protocol. That network protocol we'll call it as a Jupiter, okay. So that is a petabit network. It's a very high speed network protocol by Google, right? So we know Google from so long, right? So you know how these Google systems are matured and how these Google systems are durable, right? So the network systems that has been established between these BigQuery storage and compute are very super fast petabit networks. Okay, so that is the reason you don't see any delay. Even though it's a decoupled storage and compute, you don't see any delay. You feel that data is in a single place, right? Data and compute in a single place. So but how it is possible? It is possible because of the technology that is implemented in between these two, right? Storage and compute. So that's where you have a very high petabit network which is connecting your compute and storage. Okay, now what is the execution engine? So now we know, okay, so BigQuery storage is different, okay, and then BigQuery compute is different, okay. I mean, storage and compute are not in the same place, that at least that we are clear, okay. And the storage and compute will be connected through a network protocol called Jupiter. That Jupiter is a petabit network transfer service, okay. Shuffle service between storage and compute, okay. So this is what we know. Okay, now coming to the third part, right, which is actually the execution engine, right? So you have the storage ready now, you have the compute ready now, and the execution engine is something that you need to understand, right? So how actually when the query is submitted, how actually it will go and execute in the background, that is important. So for that purpose, BigQuery has its own proprietary, Google's proprietary execution engine, which is Dremel, right? So Dremel is the execution framework, right? So the software that will execute your queries on the compute that is available for BigQuery by using the storage that is there in the BigQuery. So you need to understand these three things: the communication between Dremel, the compute, and then storage is what your cloud data warehouse BigQuery is. So be very, very clear. Okay. So you will be connected to a Dremel, right? So your user interface will be directly connected to the Dremel execution framework. This execution framework will take your query and then it will process them in the background, and then it will use the storage layer that is there in the BigQuery, and then it will process and then it will return the data to you, right? So this is what on a high level uh, uh, how it works. You will be having one storage layer, you will be having one compute layer, and you will be having one execution framework layer. This execution framework is Dremel, okay, and you will be having compute that is obviously coming from the Google, right? So you will be having a lot of servers that are required. So the Dremel is having its own compute architecture, right? So that compute architecture, your Dremel will follow, and then your storage, right? So coming to storage also, it is very, very important. Your data in BigQuery won't store in GCS. Be very, very clear. Okay. You can store if you want, but by default, when you create tables, when you load data, right? So it won't store data in your GCS. Okay. Do not expect data is stored in GCS. So your data will be stored in your BigQuery's proprietary storage layer called Colossus. Okay, Colossus is the BigQuery storage layer, and then Dremel is the execution engine, and then the connection between this Dremel and Colossus is Jupyter. Okay, so inside the Dremel execution framework, it has its own compute architecture. Okay, it has its own compute architecture. Okay, so what do I mean by that? So in Dremel execution engine, how actually Dremel handles your query is important, right? So you have created a 1 terabyte table, and you have loaded data, and then you have loaded data continuously, and it became 4 terabytes. Okay, so the table size is 4 terabytes now. Now let us assume you submitted a query with a very complex group buys and then joins. All these things are there in that query, and then when you submit that query, so how actually your Dremel will execute that in the compute? So I told you, right? Dremel execution framework will follow one compute architecture. So what is that architecture? So Dremel have a root server, okay, which will be having a master node. So this root server will accept the request from the client, and it acts as a master node or a master server, and it takes the response from the client, and then it gives the response to the client, and also it coordinates the mixers, right? It coordinates the mixers. So mixers again are a set of servers. Mixers are a set of servers which will take the query from the root server, and they will rewrite the query. Mixers, what they will do, they will try to rewrite the execution plan for your query. Meaning, if your query is not optimized, or if your query is required some kind of optimizations needs to be done, your mixers will take care of that part. Your mixers will What your mixers will do, your mixers will try to rewrite your query or try to optimize your query. And another responsibility of the mixers is they will generate the execution plan for your query. Okay, they will generate the execution plan for your query. Okay, now your query is read, and then your BigQuery intelligence is understood your query, and it automatically optimizes your query by using the mixers. Okay, and it generates a plan for any database, any query engine, right? Even it is SQL Server or Oracle. when you submit a query, what will happen? Internally, there will be an execution plan that will be generated. Okay. So in the execution plan, we have two types. One is logical execution plan, another one the physical execution plan. Okay. So logical plan will be generated first, and then after logical plan, there will be physical plan that will be generated from the logical plan. Okay, this physical plan will be sent to the execution engine. So this is what on a traditional data warehousing side. But here what is happening, the same process. So but the different component called the mixers will take care of that part. So this mixer will, what these mixers are group of nodes, they will take your query and then they will optimize your query and they will generate a execution plan for your query. Okay, how to execute this query, that plan they will generate. Okay, now that plan will be passed to your leaf nodes. That plan will be passed to your leaf nodes. Okay, so be very very clear, that plan will be passed to your leaf nodes. Now this leaf nodes will launch the execution threads. Okay, these leaf nodes will launch the execution threads, which are called as slots. So these slots are the BigQuery's low level execution threads. Okay, so these leaf nodes will launch those execution threads on the storage layer called Colossus. Okay, so this is the full flow of your BigQuery internal architecture. Okay, what will happen? It starts from the root server, it will go to mixers, and then from the mixers, it will go to leaf nodes. So these leaf nodes will launch your execution threads. Actual execution tasks. You can call them as compute tasks. Okay, taking the execution plan from the mixers, these leaf nodes will launch the execution tasks. Okay, so this query has to be executed on these data sets and then run this execution task. Okay, thus that one execution thread or task, we'll call it as a slot. Okay, one slot. Okay, so that's why BigQuery, they will charge you based on the slots consumed. Be very very clear. BigQuery, the budget of your BigQuery usage will be on number of slots that you are using. Okay, so hope everybody got this architecture. Any questions or queries here? Are we good, or are we clear? Are we able to understand?
Yeah.
Anusha, Sridhar, Prakati,
Yes, sir.
Yes, Venkat.
Yes, Venkat,
are
clear.
we clear? Okay. Okay, fine, good. So this is what the BigQuery architecture. I think most of us got some understanding. I request, if you are not clear, please go and explore and try to see some animations or videos, so that you will get more clarity on this things, right? So Colossus is a storage layer that I told you, right? So it is actually the Google's file system, GFS we'll call it as. Okay, that is why it is also very robust and fast storage layer. So it was built on top of Google's file system. So you see Hadoop is a big data technology, right? So that technology itself has been invented by a paper from Google called this Google a paper from Google on this Google file system. So Google has released a paper on Google file system. Based on that paper, this technology Hadoop itself got invented. Okay, so you assume how actually these Google's technology are important, right? So they are the most powerful services in the world, I can say, right? So they are the market leaders, right, from so long. and they have a very strong storage and compute infrastructure in the Google's space. So you experience that when you're clearly working with the big data. I was with Azure for a couple of years, and I am working in Google Cloud Platform from a couple of years. So I can clearly sense that difference, guys. I can clearly sense that difference. They technology space is completely big, I can say, and powerful. So that is important. You run a query in Synapse, you run a query in BigQuery, you will clearly understood the difference. You will clearly understood the difference. So that is where actually the Coalesce is Google file system internally, and then the Dremel is Google's internal execution framework. These are the Jupyter is the network. So this is a high level BigQuery architecture. Fine. So let us understand quickly before going to data types. I will just show you where we can go and check our BigQuery in Google, right? In our Google project. So let us try to quickly see that. Okay, so this is our project, right? So this is our project. So here, if you just type BigQuery, right? So here, if you see, you will get a service called BigQuery Data Warehouse Analytics. Okay. So in the project space, if you go on see, right, so you will see queries, notebooks, data canvases, external connections, all these things you will see. Okay. So you don't need to bother about all these things. Okay. You just consider it as a data warehouse. Okay. uh, for now, we will come to here when we need the data. Then we will come here and we will try to see how we can actually play with the data transfer service, right? It has its own data transfer service, it has its own visualization, all these things. We don't need all these things. Okay, we are not going to discuss all these things. We are mainly focusing on the data, right? Data and queries and stored procedures and optimizations. So this is the part that we're going to focus on, right? So here you can actually create your tables, right? So we'll just try to create a table. Okay, create table, default. So BigQuery data types are a little bit different, guys. So we'll discuss about them. Same SQL complaint, guys. So you can run your SQL pretty well in BigQuery. So here, if you see, it has created a new table called EMP, and as I told you, it will support all your SQL queries. Okay, but not all the functions, I can say. You need to find out the equivalent function in BigQuery. Okay, so insert in two values, two values, one. Venkat, salary is 1,000. Okay, see here, it got inserted, and you can always query your we'll see what is this one, right? So I'll explain that to you. Okay, but when you newly open your BigQuery, you don't see this default data set. Okay, so don't get confused. So we need to create this data set. Okay, so first let us understand what is a data set, right? So in SQL Server, you remember we created multiple databases internally, right? We created one database for retail, one database for customers, or one database for test, right? So different databases we created in SQL Server, right? So depending on the data functionality, for example, in my business, I'll be having different functionalities that are happening. I'll be having logistics, I'll be having sales, I'll be having transactions, or I'll be having employees data. So I want to split this data into multiple. I want to segregate this data basically. So depending on its functionality or depending on its domain importance, so I want to segregate my data. So for that, I will create these databases. Okay, so for retail, for example, if you take Reliance, right, so it has hell number of business systems. So if Reliance want to implement a data platform, so the data will be scattered across in different warehouse platforms. One is retail warehouse, and then another one is some other warehouse. So they want to segregate the data, right? So for that, so the internal data will be segregated depending on the domain specific data. Okay, so retail data will be placed in one database, and products data will be placed in one database, something like that. But it's altogether a SQL Server data warehouse. But internal to that, if you want to segregate your data, you can actually utilize these database concepts, right? So create database we used when we are creating this retail database. We created it using create database. Similarly, in BigQuery, we have a concept called data set. Okay, under the data set, you will be having tables. Be very clear. In BigQuery, the root structure is data set. Okay, under the data set, you will be having tables. Okay, so data set is similar to the schema in SQL Server, or database in SQL Server. So we'll be having a data set in BigQuery. And initially, when you are opening BigQuery, you won't be able to see this data set. You need to create the data set. Okay, you need to create the data set. Once you create the data set, then you can create the tables under the data set. Okay, so that is something that you need to understand. Fine. Any questions still here, guys? Any queries?
Venki,
Yeah.
like databases, can we create multiple data sets here?
Yes. You can create multiple data sets linked to your project. Okay, so this is your project. Under the project, you can create multiple BigQuery data sets, and you load data, you create tables, and whatever you are doing with SQL Server, you can do that with BigQuery as well. Clear, Ranganath?
Yeah, yes, sir.
Okay. So any other questions, queries? Okay, so today we have just seen the glimpse of BigQuery. Okay, so that's all for today. I just want to wrap it up, because if I start another concept, we may end up in spending more time. So I hope everybody understood the BigQuery architecture. Okay, how actually the internal BigQuery things will work. Okay, in Monday's session, we will see the data types in BigQuery. Okay, so BigQuery data types, the most commonly used data types we will see. It supports the complex data types called JSON, array, struct, all the complex data structures we'll call it as, right? So nested data structures also it will support. So and then we will see different bytes, bool data type, and then string. So whatever the varchar that we have used in SQL Server, it is a string here. Okay, and the decimal pointers, we can use float data type in BigQuery. If you want to store only dates, you can go for date. If you want to store only time, you can go for time. If you want to store both, you can go for timestamp. So these are different data types that we have in BigQuery. Okay, and along with these, we have a lot of data types, but I specified only commonly used data types or most commonly used data types. Okay, so in our coming session, we will try to understand what are data types, and then we will try to execute our queries in BigQuery, and we will see how to create a data set in BigQuery in our next session. And we will also see how to load data to BigQuery using NiFi, using Python client. Okay, we will see both options, and we will also once the data load is completed, we will try some SQL queries. Okay, on BigQuery, and then we will see the performance optimizations. This is the most important thing in BigQuery, or for that matter in any data warehouse. And then we will see stored blocks in BigQuery. So these are the things that we're going to cover in BigQuery. Okay, we'll see few SQL functions, and then we will see the performance optimization by using partitioning of a table, clustering of a table, and we will see types of tables. There are two types of tables in BigQuery. One is external and another one is managed. Okay, so types of tables we will see. We will see optimizations, performance optimizations like partitioning and clustering, and then we will see how we can write stored procedures in BigQuery. Right, stored procedures are very important concepts, and we will also see how we can write common table expressions, CTEs. Right. So these are few things. See, remaining entire SQL is same, guys. So I'm not going to cover select, where, join, all these things again, right? So we have seen all the SQL based things, right? Everything group buys, every SQL statement that you have seen, you can execute in BigQuery, no doubt in that. Okay, so SQL knowledge is similar, but adding to SQL, what are the different data warehousing features, right? So when you're doing or storing huge data, what are the data warehousing features like partitioning of a table, clustering of a table, and creating a table from the GCS files, or creating a table from the internal Coalesce storage. So you loading the data to data warehouse platform, cloud data warehouse platform, using a third-party tools called NiFi, Python client, right? Using the BigQuery command line utility. So we'll see these three different options in our coming session, and we'll also see how to create a data set and how to load the data to BigQuery. We'll see these things in our coming session, and then followed by optimization, and then stored blocks and common table expressions. So that's where by mostly by mid of next week we can cover the entire BigQuery. Okay, and then we will jump into the data proc. Okay, so that's all I have for today, guys. Thank you so much for joining on weekend once again on Monday. Yeah.
Thanks.
Thanks, Venkat.